What's up, my friends? I know some of you are having a little bit of trouble with your science project, so Mr. R is going to do one with you. Let's get into it.
Mad Majesty!
A quick disclaimer before we start: Mr. R is fighting a bad cold, so that's why he's a day late and he sounds a little weird.
Back you cold! Back you vile fiend!
All right, so how do you even start? Start with the question. Start thinking about something that you see in the natural world that you have a question about. I wonder how much this plant will go if I start watering it 3 times a day. I wonder what'll happen to this here egg if I do this to it. Now, I'm gonna have an easy question, yeah, just to prove how easy it is. Let's check it out. I wonder if this will evaporate faster than water. Okay, now that I got a question, I'm going to make a hypothesis. Now, my hypothesis is I think that normal water will evaporate quicker than Kool Aid or soda. Now, why do I think that? I just think that because more light travels freely through water that's clear. So more thermal energy will be in the water because, none of it is being blocked or obscured. So I think just natural clear water will evaporate sooner. Let's find out. So, now that I got my hypothesis out the way, I need materials. Well, my materials are pretty simple, but my materials lead me right into what are controls and variables. Remember, controls are the stuff that is always going to be the same and not changing. It's something that you control about the whole experiment, right? Like the size of a ball, what kind of egg, what kind of plant, what kind of soil. The only thing that's changing is the variable, the thing you're testing, right? The thing you're testing is the height of which I drop the egg, how much water I give all the plants, stuff like that. Now, my controls for my materials, stuff that I control, is I'm going to control what I put the liquids in. I'm going to control how much of each liquid I put, and I'm going to control how much light each of them gets. Easy peasy. So for my materials, I'm going to pick 3 little white bowls. I'm going to pick some Kool-Aid, some soda, and some water. What do you think those 3 are? Those are my variables. Since I'm testing which one will evaporate sooner, the thing I'm testing is the liquids and how fast they'll evaporate. So those are my variables, the things that can vary or change. Yeah? So, Coke, Kool-Aid, water. Those are my variables. Now, the last thing I need that's a material, well, it's kind of just a graduated cylinder. That material is part of our control. Why is that part of our control? Because we're controlling how much liquid we put in each bowl. Because if I put 1 drop of water in a whole 2 liter of soda, of course that 1 drop of water is going to evaporate sooner. So we need a control in everything and make sure it's all the same except for the one variable, the one thing that's changing, the liquid. So how much liquid I put and the container I put it in all have to be the same. All right, here we go. Okay, now that I did my experiment, you can see that the water actually did evaporate more than the Kool-Aid and more than the soda. So my hypothesis was correct. I'm actually surprised. I thought I was going to be wrong. But now I'm going to collect all my data, which is my observations. So my data would be all those pictures I took, how much liquid I poured at the beginning, which was 150 milliliters, how long they were outside in the sun, and how much liquid I got back. So based on all of those observations and all that data, my conclusion was yes, normal clear water does evaporate faster than Kool-Aid and soda. Even though the Kool-Aid was pretty close, the soda hardly evaporated at all. So my hypothesis was correct, and the conclusion is yes, normal clear water will evaporate quicker than Kool-Aid or soda. Boom. And then that's my conclusion. And my data is all the stuff that I used. All my cool pictures, all the notes I took, all that kind of stuff. Now, I'm going to fill it all out real quick so you can see what you're going to turn in. And no, you don't need to do a board unless you get chosen in. If you're the chosen one of our class, then you're going to compete in the campus white fair. Then you'll make a board. But you don't worry about making that right now. And the PowerPoint, well, we started that in class. So all the information you take, you really just, all the stuff you wrote down and observations, you're going to bring that to class and finish your PowerPoint. And I'll show you how. Let's get into it. All right, my friends. So a lot of you are like, well, what do I actually turn in? What you're going to actually turn in is this piece of paper that you're going to turn into a PowerPoint when you come back to class. Now, if you lost this paper, don't worry. You can just write it down. If you have any pictures you want to send me, you can just send them to me on Dojo or on my website. So don't worry about it. So first, we talked about identifying the problem. Yeah? So if you have a piece of paper or if you're filling yours in, all you got to do is come over here and think about your problem. Now, a lot of you are like, well, I don't have a problem. It's okay. That's your question. So I'm going to come over here. I'm going to put my question / problem. Now for me, that was will Kool-Aid water or soda evaporate faster? All right, so there's my question or my problem. I'm wondering which is going to evaporate faster. Easy peasy, lemon squeezy. So, what's next? Let's go back to our other page. Our next part, we already got our problem. Now, we did our question, that's part of it. Now our hypothesis. So, my hypothesis is hypothesis. So, my hypothesis is I hypothesize that the normal clear water will evaporate the fastest. Now, I'm going to go ahead and put a because too. I think this because more light will pass through. Oh, come on now. Through it. Easy peasy. So, there's my hypothesis. Now let's go back. Now, I just got to list my materials. And I already did that. So all you would have to do is go and write your materials in. Now, here's the part that a lot of kiddos get confused again. Remember when I talked about controls and variables? Controls is just the stuff that you're going to keep the same that you control, right? For me, It was the bowls and the amount of liquid. Right? So, for me, I controlled what the water went into. I controlled how much of each liquid, and I controlled the amount of light. So those were my controls. All of them were the same, and all of them were things I controlled. What was my variable? The thing that changed. Well, for me, the things that were changing was the kind of liquid, right? I had water was one variable. Kool-Aid was another variable. And soda. Those things are variables because I'm testing them. They're different. Alrighty, easy peasy. Now, once you're done with that, you're going to go to your procedures and tell me exactly what you did step by step. When you're finished, this part I'm going to help you do the data. So, I'm going to come over here and I'm going to make a new page and let's do some data. What is data? For some of you, that's research on the thing you're doing. For me, my data is all the observations I did. So, whoopsie, data. Now, my first observation was there was more light visibly going through normal clear water. That was one of the first data points I saw. I could literally see there was more light going through the water than there was through the soda. Now, the Kool-Aid was kind of getting the same amount of light. So, that's my second observation. My second observation is the Kool-Aid had the same amount of light passing as the water. Right? Easy peasy. Now, there's some other things that I need to know that's part of my data. And that is, what is evaporation?
Now, I'm not going to take you through this because you do know what evaporation is, but this is when you would explain it. Thermal energy causes the molecules of a liquid to turn to a vapor.
Easy peasy. Now, what's another part of my data? The next part of my data is other observations I noticed. The next thing I noticed was after 3 hours, I could see that there was less water in the bowl. Okay, now the best part of my data. When I brought them in and I measured. Measurements. The best data. The data that proves me right or wrong. Now, after 8 hours of sunlight, toot toot, water had 60 milliliters remaining. Kool-Aid had 82 2 milliliters remaining. And soda, which kind of surprised me, had 135 milliliters remaining. That one actually really surprised me. Almost none of the soda evaporated. So there's my data. Right there are all my observations, everything I know about evaporation, and what happened at the end. This part is super important because this is the part that proves my hypothesis correct or incorrect. So that leads us to our last part, the conclusion. Now, I'm also going to help you with the conclusion. I'm just going to make another page. Whoop! Now, let's make a conclusion real quick. Conclusion. In conclusion, my hypothesis was correct. After 8 hours of sunlight, more of the regular clear water evaporated. Oops, there's no H in evaporated. Than the soda or Kool-Aid. Easy peasy. Now, with all of this stuff that I just did in a couple minutes, I would take it back to class, put it back in my PowerPoint, and I would be ready, Freddy. I hope this helps, my friends. I'm really, really sick, so I'm sorry this was fast and furious. I love you with all my heart, and I'll see you in a week. Bye-bye. Hey, friendos, thanks for watching. Remember, we can only have a brighter future with the brighter you. Bye.